Good afternoon, everyone. Today's session, we will see some of the doubts which are asked by the students in the past week and some of the tips for the upcoming assignment or homework 2 or something. And we will deep dive into PG admin, that is that Postgres tool in a in a better sense, and we will explore a lot of other options which are available in that application. So yes, before starting the session, so I want to clarify, like there are some people who asked me whether we can use Visual Studio for the database for doing their homework. Yes, you can use it, but once we get into that advanced topic like recovery or a backup or some kind of performance management, you are supposed to use Postgres to get some kind of data on that. For from homework standpoint, if you have some other tool for database to use it, you can use it. But if you want to stick with one tool, you can just work with the PostgreSQL. So that is one thing. And the second one is the assignment submission. So whoever is unlike the previous course which we had in the last period, so once you submit the assignment and it can't be edited later. I guess you have seen the Moodle announcement. It's just kind of a recap for you. So once you have understood, like, okay, this is the output, which I guess it's right. If you submit it, that's it. You can't change it later. And there are some mails regarding materials for SQL basics. So the material which we used for the last semester might not be suitable for. There are some topics here and there which will be sync with the current topics which we are discussing. But I would say using Google is more than enough, and some kind of documentation is far better than having the material from previous semester. So that is it. Let me share my screen. Yes. So unfortunately, this week we didn't have a session. But we have the recordings for that. If you see, the first thing which I want to tell you is that regarding the deadlocks. So let me give an example of it similar to this. Consider a table. Consider two persons, person A, person B, and consider a table called orders or customers. And if person A and person B are executing a process or a query, which is bound to fetch the same details of the table. For example, if I want a detail of a customer 5 from the table, I'm also executing the query, and the person B is also executing the query. So if that happens at the same time, there is a situation which will come in SQL is called deadlocks. So it is basically the same resource has been utilized by both. By definition, if we go, what will happen is, so this is like a typical simple scenario, right? If in case of a big organization of a big manufacturing plants or something, they will have like lot of informations to run, and the query will be very huge. And if if something happens like that, it will result in a deadlock. And there is a possibility, like if a person A is having a high priority deadlock, he might fetch the real information, and if the person B is having a low priority, he might not have the updated information. He might still have the old information which was shared. So that is one of the typical scenario, and obviously this will affect the performance of that application itself on the whole. And so it is basically like the basic funda is here, the performance of that application. So basically database will run on top of an application, right? So the application performance, whatever it may be Facebook or Instagram or whatever you can consider, if the performance of the database is slowed up, the application will have some impact, and you will not get the real time information of what is happening with the data and stuff. So that is one thing which you need to take care. And there are certain types of logs which you can see here. in order to counter that. So there are different ways to counter the deadlock scenario. Like last period, we had a topic called indexing. Indexing is nothing but you are able to access a particular set of data in a better and fast way. For example, we have 100,000 rows of a data, okay, of customer orders we can take, and you need to get details of a particular order. For example, 1,000th order or 2,000th order, we need to get it. If you run a normal query, it will just skim each by row, and it will fetch the detail of that particular 2,000 row. But if you have some kind of indexing, and if it has indexing for multiple tables, if you are using multiple join statement or multiple subquery statement, the fetching of the data will be much faster compared to a normal SQL transaction. So that is one of the ways you can prevent the deadlock situation from happening. For example, if I am trying to access a particular data by running a big query, if that particular database has this indexing in place, then the result will be fetched in a much faster rate, and this will avoid any deadlock condition happens to the database. And we can also have some kind of priorities in the transaction. For example, if I'm running a query, I will just have a priority like okay, this user and this particular query, if it happened from this particular thing, I will have a high priority, like, and it will happen in a sequential way. And we can also have something like a write lock or exclusive lock or something like that, which is basically you are saying whenever you are accessing that particular table, the table itself is locked from other users. This will prevent duplicate or a wrong data fetching by the other users. For example, if I am executing a query in the order table, okay, if other person try to execute the same query with the order table, it will throw some error like the table is locked or something like that. So that is one of the typical way of optimizing this kind of situation. But yeah, mostly in big organization, they uses indexing as a better option, and they try to optimize the query whichever they are running, so that it will never end up in a deadlock situation anytime. And the other one I need to tell about is that which was there, like downtime. Yes. So this is one of the typical situation if you are working in a firm which has multiple database or big application of lot of users. So before coming to this, before I started pursuing my master's degree, I was working in a client. Okay, there we used to manage like 6 to 7 database servers, and there are some primary and the secondary server. Primary was like whenever an application runs a transaction, the data will be saved immediately in the primary database. That is like real-time OLTP transactions. Okay, real-time transaction we can say, that is a primary database. And the other part of the database, which is secondary one, like a permanent database, and that will have a link with the primary database. So this is the basic structure of it. I guess you can get the drift out of it. So whenever there is a kind of an upgrade or a storage enhancement or some kind of indexing addition, typically we will not do those kind of changes in a real time. So we will have some kind of a downtime. So during that downtime, we used to take down the servers. We have to take down the application, and we used to announce like the application is gone for some time and you can't access the application and etc. And then we will do all the changes in the databases, like if we need to increase the space, or if you are adding some permissions, indexing, or changing some kind of functionality, changing a table structure or whatever it is, we have to do it in the downtime. And guess what, it's pretty tricky at times, because once you update the system and again if you try to link up the application, there are a lot of issues which will come up. So downtime is one of the most critical part if you are working in a, I would say, firms which are having application and a huge database. So that is one of the thing. Let's see. So let's see. So let's see what. Let's see. Let's jump on to the PG admin, and so this is the same thing we have seen last week. So you have to remember the password of your database, of the PG admin. Sorry, and as I mentioned, you can change your preference for the background or whatever in this preference, and these are some of the properties or whatever of the database which we created. So today let's explore a bit more apart from what we have seen last week. So there are different options. For example, there are two databases in the on the left side. You can see my screen. There are two databases in the Postgres server which I have, and one is the testing, one is the Postgres which is already created. So if you create a database, this entire structure will come along with that. So we will go one by one. So what is cached? So it is nothing but the typecasting which we use. So if you are familiar with any of the programming language, it is similar to the typecasting which we used to do. For example, uh, if you want some kind of conversion from string to integer, or integer to float or decimal or whatever, so those kind of casting can be done. So you can just define what kind of source and what is your target. For example, if I want to cast from character to int, big int or whatever, I can just do it here. So this is one of the feature you can use, and there are two ways. One is implicit and explicit. Implicit is nothing but wherever this kind of casting is defined, I mean this kind of definition is involved. So if you have implicit casting, it will automatically cast to that new type irrespective of your situation. But in case of explicit, mostly we will use it whenever you are casting within the same kind of a segment. For example, if you are casting from a character to varchar, or string to character, something like that. If you are using that, you can use explicit, and this is one of the features of this Postgres SQL. So whatever we are now seeing is all the features of Postgres. Some of them you might not be able to use it either in the course or in the future, but it's good if you have some kind of knowledge of it. And then we have the catalogs. Catalog is nothing but it's kind of a database schema or bookkeeping ledger kind of a thing, which will save all the information about your schema, data tables, and columns and etc. And you might think, or some of them might have come across Microsoft SQL, MS SQL, and in that there is a concept called schema. And the schema is nothing but which will kind of a virtual space where it will have entire schematic diagram of the database, or schematic tree of a database. So catalog is also similar thing, but the only difference is catalog will hold some kind of schema. So schema is part of a catalog. So we can take an example, like for example, there are two teams. One is like an main application team, one is support team, for example. So, and they will use similar kind of a tables and data, for example. In that case, the catalog will be very helpful. So we can have a same Postgres SQL as a data server on my left, as you can see, and inside that there are databases, and inside that I can create two catalogs, one for the development team, one for the support team. So whoever is developing will not have any interaction or duplicacy of values within those two catalog. For example, if I have a development team having a table called orders and they are executing some kind of queries there, and the same order table, or I mean the same named order table, not the same table, same named order table can be used by the other team without any interference or something. So that is the, I would say, the use case of catalog. If you are having multiple teams having using the same kind of a database structure, not the database structure, they can use catalog for to them. Then we will come to event triggers. So triggers and triggers, we will have a big chapter at the back end, so in the upcoming weeks. But to give you a theoretical explanation of what is event triggers and normal trigger, there are two triggers. One is, you can see under the schemas, you can see there are triggers function, and there are called event triggers. So trigger is basically whenever, for example, whenever the user is doing some kind of operation like insert, update, or delete to a particular table, you can invoke some kind of action for that. For example, I would say, consider table customer. Okay, if the customer is there are 100 customers in the table. Okay, if there is an addition of more than 100 customers concurrent in our website, we should have an indication like, okay, there is a 101 customer, the application is beyond the reach. This kind of a typical scenario I'm saying. So in that case, we can write a query like saying, whenever there is a customer having 101 as an operation ID or process ID, you should invoke an action like, okay, there is number of user which will not be handled by the, which cannot be handled by the application or something like that. So this is a typical example of a trigger for a particular table. So that is a trigger function which we are talking about. Event triggers are is kind of a whole. You can have this trigger for an entire database itself. So in this case, you can write it for entire database, and the event trigger functions will can be written in C language, not only with the SQL language. You can write it with the C language. So that is one of the options. So that is a theoretical understanding of event trigger. We can see it later in a better way. The extensions are nothing but, as the name suggests, it's an external entity which we can use it, kind of a libraries, you can say. For example, Python has a lot of libraries which we use. So similar to that, a pgadmin also supports a lot of libraries you can support. So in particular, there is a library called timescale db, which you can use it for time series calculation part of it. And there is something called zombo db. So that is like, it will help you in making indexes and maintaining the data for searching for searching the data in the database much easier. And there is one more called post gis or something, that is for the geometrical spatial analysis or latitude or longitude kind of a thing. So these are kind of an extension which we can use, which can be used in Postgres, kind of an external package. And then we will move on to foreign data wrappers. So this is nothing but accessing tables of a foreign database. That's it. For example, we are having testing as a database. That is our main database, right? So if you want to access some of the tables from Postgres, for example, we can use foreign data wrappers. For using that, we need to have access to that table, kind of a permission. Okay, that is one thing. And also an common users which has to be there on both the database, so that you will have the privilege to access that particular database. For example, generally in big organization, not everybody will have access to the databases. So for example, the database team will have the complete access. But if you are an application team, if you want to do some kind of search in a database or something, the access will be restricted. You might not have some permission to write, or you might not have permission to change something in the database. or view some data from another database. So that is one of the thing which will be maintained in from a database standpoint, user level kind of a thing. So foreign data wrappers, you can use it if you have the necessary permission of the particular database, or if you want to compare some data from other database or whatever. So foreign data wrappers are nothing but you can have a chance to access other database tables or columns or something like that. So for this particular thing, usually what happens is they'll create some kind of a dummy users, uh, or a user with some kind of restricted permission for that particular table, because they don't want to expose all the tables of a foreign database, right? So they will have some kind of restriction. So what are the tables you can access? What are the tables you cannot access? So those kind of restrictions will be added to the foreign data wrapper. That is the one thing. And languages, as you know, so currently we are only having SQL in this example. You can have like all the most of the programming language like Java, Python, Ruby, PHP, Unix. So whatever you want to create, you can create uh, by the definition and the handler function or whatever. So you can see for this one, they are like PL and procedural language. What is the definition and inline function and everything. So similar to that, we need to see for each language what is the inline function and what are the other parameters, and we can just use the other programming languages also. And the next one is publication and the subscription. So if any of you have used Microsoft SQL, there are like uh, that one second, there is something called, what is that? Synonyms. Yes. So there is something called synonyms, which is the same. I would say the functionality as publication and subscription. So synonyms is nothing but you are able to have a connection between two databases. Okay. For example, I have one database A, and there is another database called B. Okay, A is a primary and the B is a secondary. For example, that's what we will have. So whatever the primary database is a publisher. So whenever we type some data in the application, the data will directly go to the publisher. And if the database is publishing some information, so whoever is subscribed to that will get the same information. For example, we are having a chat box application. Okay, I am typing hi to a user. So that hi message will be saved to a database, and that same message can be seen in the subscription database. So that is the basic idea. So it's basically having a connection between the primary and the secondary database. So ideally, what should happen, that whatever the publisher database, it should publish the table whatever it is creating. So whichever table they are publishing, and if you have subscribed to the table, so whenever there is an update on the data of that publisher table, the same data will be reflected on the subscription table. Okay, for example, we are having customer table. Okay, in this example, and I am changing my email address in the primary table. Okay, primary database as some other email ID. Okay, I have changed it. So the same email ID change will be reflected irrespective of what you are doing in the subscription if you have subscribed to the table. Okay, so if another user sees that information, he can say, okay, the email has been changed. So this is kind of a flow and linkage between primary and secondary database. So if you remember, during the start, as I told you, when I was working in that, there are some 6 databases which are there. So whatever primary transactions happening in the primary database will go through synonyms to the secondary database. So it is basically like whatever information is in this database, it will be reflected on the secondary database. So that is the basic idea. So that is a feature of this Postgres. It is called publication and subscription. So if you want to listen to some other person's database, you can just have a subscription permissions and the required users created for this for the database which we are going to do, and you can get the information. And if you are not going to get the information, if you are going to publish the information, you can be a publisher also. So these are the two things about publication and subscription. Then we will expand. So, and before expanding to that, we will go to the login group roles or whatever. So this is the thing which I am saying. So currently there are a lot of inbuilt users created. For example, if you want to create a particular user, let's take an example. Okay, so I am from an application team, and database team is handling the database. So I want to see some kind of data from the database, like what are the how many people are logging to our application, how many orders we are getting per week or something like that. So I want some kind of basic permission. I don't want to write anything. I just want only the read access. So what the database team will do, they will create a user for me with my details, but with the limited permission. They will create just like, okay, Harish is the user and he will have only the read permission of the tables. He will not have any write permission. If you try to write query like insert into table and etc., it will throw you don't have the necessary permission. So that is one of the thing you need to be careful. And that is the major thing of login and groups and roles. And regarding the permission and stuff in depth, we will see later classes. And there is one more thing called table space, is nothing but we are having some kind of disk storage for the Postgres SQL. So whatever we are doing, it might be saved in a server or a cloud. So instead of that, if you want to save your database in your local disk or a disk which is having some kind of high performance, for say, for example, if you have a SSD disk with your PC and there is a hard drive, usual hard drive, you can use your SSD for some kind of partitions and some kind of particular servers of your Postgres, so that the performance of that particular server might be way better than having a Postgres in a hard disk, right? So that is one of the thing which we can do with the table space. It's like physical storage for your database. That's it. Instead of having some kind of lingering over the cloud, you will have a physical storage. And it is basically if you have any space issue or something during your so currently we are having kind of a lightweight, but if you're having a high-end application with a lot of users doing transactions, and your database data will keep improving, right? Keep increasing, for example. So whatever transaction in the sense, if a person creates an account, that data will be saved. If a person browses something, that data will be saved. If a person do some kind of activity, that data will be saved. So everything is data and it will be saved one by one in your database on top of everything. So usually the database size will keep increasing it. So whenever there is a space issue, in order to uh, handle those kind of a critical situation at that particular moment, we can use this table space to have some kind of a I would say the second way or the alternate way for handling the database at that point of time. So these are the login and group roles. Let's expand schemas. So in schemas, there are like usual stuff which we already see. You can create table like this, and you can columns, and you can add your columns, advanced constraints, whatever the primary key, foreign key, check, unique, exclude, whichever we have seen in the last class. Or you can also write it in your query tool, like create table and whatever you want to do, the column names and the permission, not null or auto increment or whatever. So tables are usual things which we already discussed. Trigger function, we already told this will only support from a particular table point of view. If you want to use even triggers, it will use it for the particular complete database. Okay. And uh, views are nothing but a virtual kind of a table. Okay. For example, you are writing select select star from whatever customers or something. Okay. This is one of the, I'm giving a vague example. This is one of a basic query you are writing, and you have to write this query, or you have to check this query every day. For example, okay, you want to have some kind of data, and you are having some kind of regular checkup to have some kind of thing to check every day on this query. So instead of you writing this query every day and executing and seeing the data, we can create a view for this query. Okay, we can write like create views and view name. Okay, and then we will write all the SQL part of it inside the statement. So whenever we create a view, and the view will be created here, so whenever we click on that, it will just execute the query and we can see the latest data. So currently you can see it is very simple query, select star from customer or something. Imagine if you are accessing a database having multiple tables and multiple join statement and multiple conditions. So you don't have to write every day that particular query. You can just create a view, and you can just see those data. That is one of the use case of views. There is one more thing called materialized view. So materialized view is nothing but it is also a kind of a view. Okay, so ideally the major difference is views will not be saved anywhere. It will just be like it will only save the query which you are saving. I mean, it will save only the select star from customer. It will not have any data or whatever. It will not have anything. But materialist view, it is nothing but it will save the data in a table or a disk. It will virtually create a one more table. For example, we are creating create view, view name and the query, right? So view name will be created as a table, and it will be in the materialized view. Okay, and there is an option, and for example, there are use cases like you want to have some kind of data. Okay, and you don't want the data to be changed. For example, I am an executive from a company and I want to save that data or slides, statistics which I'm going to show in the slides for a period of 30 days or something. I don't want to change it. In case of views, what will happen is it will update automatically whenever there is a change in the database. But for materialized views, you can create the view and keep it. If you want to change, or if you want to see the real-time database, you can update by refreshing manually. So that is one of the use case. So if you want to see, okay, once in a month, you don't want to see it changing every time whenever you see it. You want only at the month start or month end for that meeting or something, whatever. So you can use this materialized view and create your SQL statement there. So whenever you need it, you can just update it. You don't need to you don't need, it will not get updated frequently like the views. So that is one of the difference between views and materialized views. And other thing is procedures and functions. So this and this. So store procedures and function, uh, I would say it is more or less same, but there are still differences. So procedure and functions are like it is typically an operation which you want to do in a particular table on a regular basis, or whenever you want to call it, whenever you want to use that particular function in your query or whatever. Okay, for example, take addition function. Okay, you want to use that addition function in your SQL whenever you call that function in a query or something like that. So that is one of the uh, thing, as the name suggests, and if you have used any programming language previously, function is nothing but you can have some kind of operation inside. So store procedure is also a function. I mean, it's also similar to function. I won't say it's a function. The major differences between store procedure and function is you can have multiple functions inside a stored procedure. Okay, that is one of the case, but you can't call or have a store procedure inside a function. Okay, so that is one of the difference. So store procedure, inside that you can have multiple function call, you can have multiple functions, but in a function you can't have that. That is one of the main difference. And the second thing is procedures are always cached. Okay, for example, I am creating a store procedure for multiplication or division. So whenever it runs the first time, it will compile and then execute, right, according to the programming concept. But if you are using a procedure, it will not compile the next time, it will just run it. So in this case, it will reduce the operation time or something. It won't have much difference, but if you see a long procedure, which is we used to run when I was working, it is like it will take. We used to run some store procedure, uh, and it will take 18 minutes, 19 minutes. So it will keep running in the background. So if it executes and runs, it will take much longer time. So procedures are advantages in that way. So that is one thing. And stored procedure doesn't create any, I mean, doesn't return any result or a value. Okay, it is just an operation which is supposed to be run or something. But functions, you can just give some input and get some output. So that is one of the thing. And in procedure we can commit and roll back a previous transaction which happened. So on the bird's eye view, you can say, I have changed my password, for example. Okay, that is a transaction which I'm doing in an application, and it will be saved in the database. So using procedure, there is a possibility you can roll back that particular change, or you can also commit that change. But in using function, that is not possible. So that is one of the difference between functions and store procedure. And then we have sequence or nothing but it is similar to creating I mean sequence of numbers, as it says. So whether it can be an incremental order 1 2 3 4 5, or it can increment in a different order 5 10 15 20 or something like that. So those kind of sequence or a particular table you can create instead of 1 2 3 4 5. So that is sequence. And there is the aggregate, which is nothing but the aggregate function which we already discussed. Those are the uh, count, min, max, average, and sum. So those are the aggregate function. And the rest all is, I would say, I mean, most of the things which we saw today, I mean, some of them are useful and some of them are helpful for you to understand from the concept point of view. But most of them we might not use unless we utilize in a big kind of an application you are handling. If you are handling a big application or something like that, otherwise it's we don't use it much. Uh, but apart from that, rest are not needed. And before that, so let me 1 second. Let me open the yes. So in your homework one, okay, as I said already, there are three things you should know. One is the joins and or subquery. You can write it in any way. Extract is the command which can be used for the datetime, and ISODO or DOW. DOW is the day of the week, or ISOW for the thing for the extraction of the day and time, day of the week, or what is the code for the week. For example, Monday it is 0 for ISODO or something. So these three things, if you have some kind of understanding, I would say the first homework is straightforward. You can just do it off. And there are some cases like I would say using a subquery is also fine, but try to utilize joins, which is much more efficient. And as I already told you in the last session, so in joins there are four types predominantly, and we will use mostly of inner join, sometimes of left join. That's it. We will not use any other join. So inner join is nothing but the intersection of two tables, and left join is nothing but we will have all the data of the left side table and the intersection of both the tables. So that is one of the things which you need to understand. And for the homework 2 partition, I believe we will have a detailed class on the upcoming week on this topic. But if you want to try it before that, I will give some kind of hint on this. But we will discuss this and store procedure in a detailed way next week. Okay. So we will have some examples of partition, how to work on partition, and what is the store procedure, and etc. etc. So what is partition is nothing but as the name suggests, it's nothing but separating the data or segregating the data from a table. Okay, and there is a similarity between partition and group by. So partition is as you know, group by is last week we have seen if you are using some aggregate function. Okay, for example, there are 10 customers. Okay, and there are multiple orders. So if you want to get the customer 2 who has bought and how many orders and what is the amount of purchase he got, so we can use the sum function to get all the customer two's order and this purchase amount, right? So that is group by. But if you use partition by, it will have kind of one row per instead of one row per group, it will have it will display the data of each value. Okay, for example, it will display customer 2 order 1 this much, customer 2 order 2 this much. But if you are using group by, it will just say customer 2 order number, and this is the total amount of all the orders. For example, 5 orders means 10, 10, 15, 20, 25, and 30. So it will just add all that numbers and it will just throw in a single row. So in partition, it will have some kind of it will produce each orders in a different row, and it will say, okay, for one you have spent this much, for two you have spent this much. And there is one more advantage in partition by is nothing but you can use aggregate function and var class. So we have seen in the last class, like when you are using an aggregate function where you cannot use, you have to use having. So, but if you are using partition by, you can still use var class to add some more conditions to that. And apart from that, I will not dwell on to that too deep. So this is a basic overview of partition and group by. It is generally like instead of giving a cumulative data in a single row, it will give a detailed data of each row when you're using an aggregate function. That's a difference. And yes, so what more? And there is one more thing, like there is an way you can change ports in your I would say the SQL. Okay, so default the Postgres will save it in 5432 or something like that, as you can see on my screen. And for example, if you have some other application running in parallel, there is a chance that it will collide and the Postgres will sometimes throw an error. So you can either change it, or it has that I would say that it will change it automatically, or you can just uninstall the Postgres, and when you install it, you can change the port number. It will have some kind of I would say in between it will ask, I believe. So you can change that port number in that point of time itself. So changing port is one thing you can do. And yes, so these are the things which I needed to explain today. And if you have any doubts or questions, or if you are not sure what about certain concept, please do write me a mail. Okay, and I will get back to you as soon as possible. And Regarding next lecture, we will work on trigger. We will see the partition and the store procedure in a detailed way. So currently we have seen, I would say, most of the features of Postgres application and theoretical understanding of most of the things. And from next week, we will directly jump onto the partition and things in a deeper way. So do write a mail, and thank you.